Okay, let's review mismatch repair because the figure in the book is kind of complicated to understand. Excuse my squiggly lines. Okay, so this is a strand of DNA that is being replicated. And usually you have G paired with C and A paired with T. Now what happens if you have a mismatch? For example, G paired with T. Well, the thing that it's gonna do is that because it's not matched properly, it's gonna distort the strands, right? Now the first step of the mismatch repair is the mut S protein is going to detect this mismatch and it's going to bind to it. So here we have our mut S that is bound to the mismatch base pair. Second thing that is going to happen is the mut L is going to bind to the mut S. What this complex does is that it will recruit mut H. Let's put mut H here. Mut H. And basically the role of this complex is that they want to take this out, right? But they need to do it without harming the parental strand, right? Because this is only the strand that is being replicated. Because if they were to change this one, right, which is the parental one, it would mean that all the other DNA that gets replicated and the RNA that gets replicated would be mutated, and this cannot happen. But they have a way to differentiate between the parental strand and the daughter strand. There is something that is specific to DNA that is fully replicated, and that is that it is methylated. And what it means is basically there is a site that is called the GATC site, and so the other way would be CTAG, but it reads the same, you know? It's a palindrome, that's how it's called. And this adenine here is methylated, which just means that there's a methyl group on it. And this one is too. So this is specific to DNA that is fully replicated, because while this daughter strand is being replicated, right, it is not being methylated. But since this one is the parental one, it has already been methylated. Somewhere around here, there is a GATC site, and well, this one is not methylated because it's on the daughter strand. This one is. So the way that they're going to differentiate is that they're going to find which one out of these two are methylated. And so what happens is that this complex's job is to look for the GATC site to see which one is methylated. So what happens is that until the mu-H finds a GTAC site, frick, I said it again, a GATC site to bind with. And so what is going to happen is that there is going to be a sort of loop. So actually the mismatch would be sort of here, and I'm not gonna redraw everything, but the complex of mu-S and mu-L would be here. And then when mu-H has finally found the GATC site to bind to, that's when it can do its function, and it is going to cleave. Oh look, I already even drew it. It's going to cleave this part that is unmethylated. So now you have the daughter strand cleaved, and mu-H unbinds. Well, this leaves room for another protein, which is called helicase 2. And what it is going to do is that it is going to unwind the daughter strand from the parental strand. So you're going to have this strand here, and that is when the mu-S mu-L complex is going to detach from this place. So that's the action of helicase. So that's what helicase 2 does. But then we still need to cleave this part, which is the original error, right? And that is going to be the job of DNA polymerase 1, the exonuclease. And this is the protein that is going to cleave here. So then this is all gone. The mistake is erased, but it is not still corrected. The protein that we need is another DNA polymerase 3 to come and fix the mistakes that were made by the previous one and put an A instead of, I don't know, what was the original mistake, a G maybe? But yeah, and it will continue the rest of the strand. Oh, and of course, as it continues the rest of the strand, and here, let's say, I don't know, we have a C and a G. Well, these two are going to be bound together, right? Because the DNA polymerase is only replicating the top one. But this one and this one are not going to be linked. So this would be gone, right? Because it would have glided along here and then went away. But you need one last protein, which is a ligase, to come and give these two a little phosphodiester bond and make them link properly. So this was an explanation of the mismatch repair mechanism. It is one of 6 mechanisms of DNA repair, and I will cover the other ones in other videos, so make sure to pay attention to that. And good luck.